Bueno, buenas tardes.
Okay, good
Gracias a todos por estar
afternoon.
aquí.
Thank you all for being here this
Vamos a ver
afternoon.
el taller La llamada de la muerte.
Let's
¿Vale?
see the call
Imagino
of
que muchos
death
explicarán
this
mucho la
afternoon.
curiosidad del porqué
I'm
de
sure
este
you're
título. Eso viene al
curious
final,
about why I've
Vamos a
called it this,
comenzar.
but we'll see that at the end.
Bueno, tenemos un pequeño
Let's
índice
start. We've got a bit
con
of
los 7
an
puntos que
index
vamos a ir
here
explicando,
with the
¿vale?
7 points that we're going
Primero,
to
¿de qué va
cover.
esto?
So,
Ahí voy a
first of all,
hacer-
what
voy a
is
explayar
all of
un
this
poquito, ¿vale?
about?
Voy a-
I'll give a little bit of an
aburriros un poco
explanation.
sobre de qué va a ir el taller.
I'll tell you all
Os voy a
about
explicar,
the workshop.
la voz IP.
I'll tell you about Voice over Internet Protocol so that you get familiar with that and what we're going to see, because we're going to see it right through the process. We'll talk about IoT, Internet of Things devices. It's an RPI device, and we're going to use Arduino as well, the two systems. Then we'll set up a telephone switchboard, and we'll install it on the RPI. Then we'll see a little bit about the commands and scripts, how it works, and we'll play with our switchboard a little bit. So we can put the commands and script into play. And then last of all, we have got the call of death. And last of all, we'll have some advice and countermeasures to protect ourselves from attacks of this kind.
Pues nada. Comenzamos.
So let's
Esto es un taller de
begin.
iniciación,
So
como bien
it's
sabéis,
a
por lo cual
beginner
vamos a
workshop,
profundizar
so
mucho
we're not going to go into great detail from a technical point of view, so that everybody can understand whether you've got a lot of knowledge or not.
Bueno, a cualquier sistema creado se le puede dar
So
una función
any
más allá
system
para la
that
que ha sido
has been
diseñada,
created, you can give it
siendo
more
ese en esencia el
functions
espíritu
than
del
the
hack,
ones
¿de acuerdo?
that has been
Llevar la
set up
tecnología
for.
más allá, ¿no? Saltar las barreras
So
establecidas
we're going
para
beyond
ampliar el conocimiento
the
y mejorar el
barriers
futuro.
to
Básicamente es la
get
definición que tengo de lo que es
greater
esto.
information and knowledge.
Contexto muy amplio,
This is
muy
basically
largo.
the definition that I
Un hacker
have
es una
given to this.
bicicleta que exprime las
So a
tecnologías,
hacker is
medios que
somebody
tiene a su
who is
alrededor,
interested
crean
in
lo que
getting
sean
most of
para
the
crear nuevos
technology and the
caminos,
means
crear nuevas
around them
tecnologías superiores a las actuales, o
to
simplemente para
create
solucionar
new
problemas como nadie antes
routes
lo había
or
hecho.
things that people
Un
had
hacker
not
puede saber de
achieved before.
programación, de
A
diseño,
hacker
de
can
redes,
know
de
about
sistemas,
programming,
electrónica,
design,
física,
network,
química,
systems,
psicología.
electronics,
Uno
physics,
puede ser
chemistry,
hacker, sea
psychology.
cual sea su rama.
Anybody can be a
Ser hacker es lo
hacker.
más. Y lo mejor es que puede ser
Being a
cualquiera.
hacker is the
Yo
best,
realmente el
and
término
anybody
hacker
can do it.
Lo comparo
I
a lo que
compare
más se
being a
aproxima en el mundo
hacker
real a lo que sería
in
un
the
superhéroe.
real
Los
world
superhéroes
with a
sabemos que son superhéroes, no son reales,
superhero.
pues lo más parecido
You
en el mundo
don't really
real
have
sería un hacker.
superpowers, but in the real world it would be a hacker.
Ahora viene cuando os aburro un ratito, ¿vale?
So this
Un
is
poco de
the
teoría.
boring bit, I'm afraid.
Vamos a comenzar con la voz IP. ¿Qué
So
es la
let's
voz
start
IP?
with
El nombre ya lo dice, ¿no? Voz
VOIP,
sobre IP, sobre el protocolo
Voice
de
over Internet
Internet, ¿no?
Protocol.
Es el acrónimo sobre el
It's
protocolo de voz sobre Internet.
VOIP is the acronym for Voice
Y
over
esto
Internet
básicamente simplemente
Protocol,
lo que hace es que
and it
toda
just
la tecnología
means
que
that
tenemos
the
actualmente,
technology that we
a través de la
currently
cual
have,
funcionan las comunicaciones,
through
¿no? de
which
datos,
telecoms
pues, lo que es la voz
works,
convencional
data
de toda la vida,
telecoms, voice
convertido para que
that
se
we've
pueda
always
utilizar a
used,
través
has turned
de la propia línea de datos. ¿De acuerdo?
into something we can use over a data line. We
Como puede
had
ser, como podría ser este
analog
teléfono que tenemos aquí,
lines,
con
such
barra
as
de
the
cobre.
phone that we have
Esto
here.
no transmite datos, no,
It doesn't
¿de acuerdo?
send data.
Hasta que se inventaron los modems.
And then we had
A través
modems.
de esto es con lo que vamos a controlar toda
And
una centralita.
through this, we can use it to control a switchboard.
Bueno, ¿podemos utilizar los dispositivos analógicos?
So can we use
La
analog
respuesta es sí. Claro,
devices?
dentro de la voz IP,
The answer
volvemos
is
a la
yes.
diapositiva anterior.
So through the
Básicamente, para
VOIP,
poder
if we
utilizarla,
go back a
necesitas o
second,
bien un teléfono IP,
you either need
¿no?
an
dedicado exclusivamente a ello,
IP
o un
phone
teléfono IP por software,
or
¿no? Puede ser
a
un teléfono
IP
físico,
phone
o
through
puede ser un
software.
programita,
Can
una
be
aplicación
physical
instalada en tu ordenador,
or
en tu
a
smartphone,
program
que
on your
utilice ese
smartphone or
servicio.
your computer. It uses
Por
this
ejemplo, las
service.
llamadas de WhatsApp,
For
las
example,
videollamadas de
WhatsApp
WhatsApp es voz
or
IP.
WhatsApp video calls is VOIP.
Los dispositivos antiguos.
So
Cualquier
the
dispositivo
old
analógico
devices, There you have several examples. A telephone. I'm sure you've either had them at home or you've seen them at some time. Kind of old telephone, and the one you can see at the bottom is actually the one we have here today. So all of these devices can still be used thanks to one of these devices that does the conversion from analog to digital or digital to analog. There are a number of ports, an Ethernet port that does the connection to the internet or to the network, and then it has the FXO or FXS connections. And this goes from the digital line to the analog, or the analog line to the digital. You can configure it in a switchboard in order to be able to use that. So let's see the Internet of Things devices. So we have mini PI computers.
Los dispositivos PI, que es como los conocemos todos, pues son ordenadores de placa única.
PI devices are little computers with a single board computers, and you can see an explanation of that on the internet, as in the paragraph we can see up here. So Raspberry Pi were the ones who initiated these kind of devices, and they set them up for teaching purposes, for teaching, programming, computing in schools, secondary schools, and so on. And now its use has extended a lot, especially in the world of hacking, in maker projects, in robotics. So the use has been extended from what it was initially created for. So as well as Raspberry, there are many other different manufacturers, and each has their own version. We have Banana Pi, for example. So if you just have a search using the term, then you'll find many. There are different kinds of design, different processors, different kind of RAM memory, and the one that I have chosen is a Nano Pi model. It's the one that you can see down here. You can see the plate at the top, and then the apparatus at the bottom. It's a little bit bigger than the size of a nut. It's made of aluminium, the housing, and it's quite powerful, even though it's very small. It's got 1 GB of RAM memory, and the Ethernet has 1 GB as well. So it has a lot of power, more than what we need for what we're going to do here. So here we have the scheme, the diagram of that plate. These plates have a number of different connections that we can use in our projects. It's got a card reader, inputs and outputs, which are the ones that we need to send and receive information from the device. So in those connections, on the outside you can see that there is a display where you can see different things, and there are 3 little buttons on there. So the image on the display and the use of those buttons is programmed here in these pins. So in the pins here you could connect pretty much anything. We could use anything. We've got an example of use here. And using this little script that you can see, we can turn it on and turn it off, or connect a relay, or connect it to a domotic system to use this apparatus. And just with a little bit of programming, and something has gone a little wrong here. Oh, it's back now. It's just the cable connection. I'm sorry about that. We could connect pretty much any device, a camera for example, and there are many projects that connect a camera, and it's used for IA, face recognition, and so on, for many different uses. Any of you know a little bit about programming? This script is very simple here. At the top we put vi-led.py, and it's only got a few lines there. We just import the recognition library from the plate, which is rpi.gpio. We do a copy of the time model, and then we have a variable where we say the pin number that we're going to use. You can see in the image that we need 3 pins for the in feed. So it will be through the number 4, pin GPI 4, and then pin 6 and pin 7, which is where we send the command. So basically that's the switch. So we create a loop where we're waiting for the code, for the command. So the command is actually programmed a little bit later on, but we're making a loop here to say turn on and turn off. So this is just the on-off programming until we cancel the script. So down the bottom, if you're familiar with this, once it's created and stored, then we have the execution permission, and we can execute that. So, Horus Box. Many of you will have come as a result of the communications that we have made of Horus Box. It's a NanoPi that we've integrated some tools that come with Linux, and we've created a hand device that can be used for pen testing. Here's a little bit of detail about that, about the device. And in addition to these tools, and you could connect through Linux, we have also added some functions to the apparatus for control of the buttons. Once we've controlled, programmed an MP3 device, we can do pause or increase the volume and so on. In this case, we've programmed it so that we can say if we want to do a network scan, the type of scan, and we can collect the packets of traffic to which we're connected. We can export through the USB ports, use the menu to select that, and export onto the drive that we're using, an external drive. And in the photo, there is an example of how it has been used. It's a battery, a power bank, and the device is connected to that, the NanoPi device. There's a telephone that is connected to the NanoPi, and on the left we have a Wi-Fi repeater, a USB memory, but it's got a Wi-Fi server. So the RPi and the mobile are connected to that, so they're all interconnected, and once you've done that, you can start working to look into networks or whatever job you need to do. This is a simulated way. If you're in a place where you don't want people to know what they're doing, if you're in a company and you don't want them to realize, you can put this device in your pocket and you can continue working with your mobile phone, and there would be no suspicion that you're analyzing the network in that company, so that you can issue a report for that company. So you can see what employees are doing in a given moment, because people would not suspect that you're there to do that job. It just seems that you're working with your mobile. When people are on their computer, they might be looking at Facebook or doing other private things. So it's a great option to do this kind of investigation, even when you're actually physically in the company without people realizing. So you can see changes in behavior. On this occasion, what we're going to do is to use the NanoPi with a phone switchboard. We'll use the asterisk system and we'll do it directly on the screen so that you can see it has sufficient power to manage a voice system in a company. This could easily manage this in any kind of regular company, in standard roles, sales role, and we can configure everything. So with just one device, it's sufficient. We don't need any kind of huge system. Just with this piece of apparatus, we have enough in order to be able to work. So let's have a look at Arduino now. I have included Arduino because this is a beginner's class, and we're going to have a little bit of a look at everything in terms of electronics and informatics. Actually, we don't actually need Arduino here for what we have here. With our piece of apparatus, we have sufficient to do what we want to do, but I wanted to add something extra so we can see how Arduino works as well. So what is an Arduino plate? It's a plate with a programmable microcontroller, and we can do pretty much whatever we want with that. It's got free hardware, open source hardware, and there are different connections between the microcontroller and the different sensors so that we can use it in a very simple manner to test new designs and create new projects without needing to invest initially in expensive prototypes or personalized plates. This can be pretty expensive initially because any project that you do, you have to buy the plates. There's no system that is ready that I can use functioning and operation quickly to see everything that I want to do and do plenty of tests. So now with this, I can send the information to the manufacturer. So what we achieve with this device is exactly that, and we save a lot of money, which is great for companies. It's a homemade device, and with these kinds of things, you can do pretty much anything you want at home. Hackers do many things with these kind of devices. I'm sure you look at that on YouTube, and they can do pretty much anything. They can do almost magic with a device like this. There are many types of Arduino plates: Arduino Uno, Leonardo, Mega, LilyPad, and some have Bluetooth included in the Arduino BT, but the difference between them is the number of ports, the memory capacity in the microcontroller, and based on the memory you can do bigger or smaller projects. The format and also the size. But the functions are pretty much the same in all of them. Some of them have different options than others. So how do we program Arduino? It's basically an application that you can use to select the Arduino plate that we have got, and you can write in the code. Once that is done, we have the option to upload the program that we have done onto the memory of the device. And once it's been uploaded, it is programmed and we can use it to work. This is free, it's open and available for all platforms. The new version just came out, in fact. So the code that we're going to upload onto the Arduino plate, this is what you're going to see in the workshop. And we're just going to do something with the plate now. So we're just controlling one pin, the option. So through the serial connection, this is where you can establish a connection between the computer and the device. We're just going to set up a loop in which the Arduino just waits for the communication through the USB port. It's going to be waiting two things, either a 1 or a 2. So when it gets the 1, it will start up the feed, put it online. So we'll allow the power to go through, and when it's on 2, we do the opposite. It's like a switch that will be told to switch on or switch off.
And with this, for example, if we connected it through to our lighting system at home, then we would have a switch that we could control from our computer. Or even if we do it through a web interface, then we could control it with a mobile phone. And the coding is very easy as well. You just add the serial connection, there's a wait, and then the loop is waiting to receive one thing or the other. Now, how do we fiddle with relays? We're going to see a relay because what I want is to show different devices, electronics devices, because that's what I like. So relay is a switch as well, but it separates the on and off orders from the power or the device that it turns on and off. So one of its greatest advantages is that with a very small system with 3.5 volts, for example, without much power, I can turn on and off that switch, and I can have anything connected to it. I can have light bulb connected with a battery, a 12-volt light bulb, and even something in 220 up to 10 amperes. And now let's create our asterisk switchboard. What is asterisk? It's an open source software developed by DTMF, who is from the US, and it gives you all the functionalities of a switchboard onto our computer, regardless of the kind of computer it is. So we could turn our computer onto a switchboard with absolutely every single functionality that you can imagine. One of its strengths is that it also allows you to unify voice IP, GSM, and PSTN. So everything that we have right now, be it wireless or through cable, you can unify it into one device. This is very widely used in companies and in corporations because it has many functionalities and it's not very expensive. Imagine the most expensive thing that a company would need to have to install Asterisk is the configuration, because it barely needs any software or hardware. Now, installation and configuration. Those of you who have your laptops with you, if you're connected to the Wi-Fi, then you can start trying this. We can go about this in different ways. One of the most common ways is to download the repositories from the maker's website. You've got the address there at the bottom, asterisk.org/downloads. You can see all the available versions there, because there's quite a few simultaneously valid right now. One of them has the newest options, which is beta. It's not being produced. Then you've got the one that companies usually use, and then you have the older versions as well. Now you can, as I was saying, download it, decompile it, and execute it, and then you would have it on your system. Now, depending on what Linux you are using, Asterisk, by the way, is designed for Linux, then you can do an apt-get install asterisk or yum install asterisk, depending on what you're using. Now, why do I not like using this option? Because you cannot choose what is going to be installed. The system is going to install anything that's on the repository on the Linux system that you have. You might want version 16, but on the repository there's only version 13, and so there will be different things. So what I usually recommend is to download it directly from the website. Now, important files and routes. Asterisk has thousands of configurations with different links as well, but what is most important for us is the files that you can see here. Configuration files are all in etc/asterisk. We've got zip.conf or pjzip.conf. Depending on the configuration, we'll work with one or the other, and the second one is an evolution of the first one. We can configure extensions, trunk lines, and SIP lines. So if I have 10 phones with 10 different hosts, then I would configure them on the zip.conf or pjzip.conf. Now, if I have an IP telephone provider with 1 or 2 lines, then I would introduce a configuration on that file too. Then we have extensions.conf. That's where we configure the dial plan. That is really the core of Asterisk. Now, on extensions.conf is where we're going to do in detail everything that our switchboard is going to do. That's what we're going to detail what it's going to do. We have features.conf. This is where we have additional parameters and features, such as dialing, waiting time, background music, and everything. Then we've got manager.conf, where we configure users and permissions with access to the AMI. And we'll see later what AMI is. And for me, this is the most important thing of what we're going to do on Asterisks today. And then we've got a series of folders, voices and sounds that you have on the switchboard on var/lib/asterisks/sounds. They're all in English, and you can also download them in other languages from certain places. So you could have the switchboard on whichever language you want. And then on USR lib asterisk modules, we have the libraries, applications, and modules, and there are many by default. And then var/log/asterisk is where all the logs generated by the switchboard are going to be saved, be it calls that are made, failures, everything and anything. Now, zip.conf file. Here you have a general part where you have the configurations that are going to be used by all the extensions that we later configure. And we have an extension part. As you can see, they're in the center. And we're going to write, first of all, what is common to all extensions, and then we configure one by one. So, for example, I use 1000 numbers, so I can have extension 1003, 1002, 1003, 4. You can have whatever configuration you want, by the way. And then each user will have a caller ID, which can be a number or it can be a name. 1001 Jesus, 1002 Daniel, etc. Now, secret is the password that user, and because this is a cybersecurity event, I would like to use the most famous password of them all, 1234, which is the one you never should use, by the way. Now, extensions.conf. This is, as I was saying, the core of your switchboard. You will always have a general part here as well. We're not going to go into detail on all the lines because there is a lot of things and you might get bored. But if you do want information, you just look up asterisk on the internet and you will find tutorials and manuals galore. So, what we're going to configure is the default. That is what we're going to do by default when we get a call. As you can see here at the beginning, there's an answer. Then there's an extend, which dials the IP line. Before we have configured 1001, 1002. Here I'm missing 0, but so it shouldn't be /101. It should be /1001. And then after answering, it would hang up. Now we would have configured 2 outgoing as well, 2 blocks, extensions, which is what manages calls between extensions within the company, and then services, which is where you can have number of contacts or telephone numbers, or services such as Hola Mundo, for example, Hello World. If we call 123 from our phone, then we will get an answer with a voice saying Hello World. If we have the time service and we dial 403, then we will get an answer saying today is this day on this month and it is this time. And then, I mean, you can program anything you want here. If you have an internet service where you can check the weather, for example, in a specific location, you can create a menu that accesses that website. And depending on the codes that you send or that you dial, it can tell you what the weather is like or what the motorways are like, depending on the numbers that you choose. And then when it comes to command and script execution with the IVR menu, which is the one we have prepared, the one we're going to look into in our concept test. So we have prepared a telephone number. Many of you will know it already. When we call that number, the system answers and it executes a voice menu. Typical welcome to here and so, please press 1 for this, please press 2 for that. Once we've accessed that menu, then we have a waiting time to dial the option that we want to choose. So it's usually please press 1 to talk to our sales department, please press 2 for our technical support department, and so on. So in our case, we have configured it in the following way. If we press 1, we activate Arduino exit. If we press 2, we deactivate Arduino exit, so we could be turning on and off our relay. And what have we achieved with this? That through a telephone switchboard in a place thousands of miles away from me, I can turn on and off the lights in my company, or the alarm, for example, without even needing to use the internet. I just make a phone call, I call my company, and depending on what I dial on my menu, I turn the lights on and off, or I activate the alarm, for example. I just need a normal telephone connection, by the way, not even the internet, as I was saying. So, on our third option, we execute scripts through AMI, number 4, and Nmap in the network. So remotely, we were already starting to do things without even needing our computer. So I can do an Nmap onto a network and see which machines are listed and what reports are being sent, and I can say that send that to copy-paste. With a little parameter to then, through the search on the website, I can find that result. That would be one of the options, right? Then there's another option, AGI execution, and the final option we are executing here, self-destruction command, so delete evidence. So with this device, which we could have connected anywhere, by the way, this can be used for good or for bad, obviously. If you want to use it for bad, you can just connect this with an IP telephone stolen or configured on your switchboard, and you can connect or hide that device within a company's network. Or if you don't have access to the network, you can connect it remotely through the Wi-Fi and just hide the device on an external part that has connected onto the Wi-Fi for that company. You don't even have to get physically into the company, you just need to connect to their network. So just imagine that remotely, without even needing internet connection, you can do a pen testing, depending on what you program on your device. So once you've done all those working options and configurations within your network, then you can self-destruct. Say your USB device has a USB killer connected, you can activate the USB killer. So you would just literally kill the machine. So there would be nothing to investigate or to learn from that device. No one could know what that device has done. Now, this kind of attack, which consists in hiding this kind of device, maybe you have seen it on TV. A couple of years ago, there was an attack on one of NASA's servers in their lab, where in one of their connection rack, amongst the different cables of network connections, there was an ADP device hidden, which was taking all the connections and sending them to God knows where. So this would be the same principle, but you would have one advantage, which is by using an analogical telephone device, which then self-destructs, there would be nothing to analyze because you're not even using an internet connection. Because at the end of the day, you can trace internet connections. It might be more difficult or less difficult, depending on whether you're using VPN or Thor, but you can eventually trace it. Now picture someone executes this sort of attack on a remote place in Australia, in the middle of the desert, where there's only a telephone box. And there's no internet connection of any kind. And then the company is victim of a cyber attack, and the company that has received the cyber attack, if they launch an investigation, the only thing that they could find is that they have received an internal attack. So the person who has eventually launched the attack via phone will never be traced or found. Imagine, instead of a USB killer, you have an exploding device. And this would be a way of perpetrating terrorist attacks, for example. So this is this kind of attack we haven't really thought about that much, I don't think, when you can unify these two types of technology. So this is something that can be very powerful when used for good, but very dangerous when used for bad. Then we have command line interface. Now, on our Asterisk switchboard, there's a console where we can visualize everything the switchboard is doing. And we can modify data, and from that command line, we can reboot the switchboard, we can upload services, stop them, we can see configured lines, and stop them, and see how they're working. So we can see basically everything that's going on in real time. And then we'll see how it works. And now let's start fiddling with the switchboard and playing around with it. Now, how can we interact with an Asterisk switchboard? First of all, we can work with AGI, Asterisk Gateway Interface, and here we have a series of libraries and frameworks that we can use. It can be in Java, Python, PHP, .NET. And with this library and the Asterisk Gateway interface, what we can do is interact from different programming languages with the actual switchboard. But you have to take into account that working through AGI is a bit limited in a way because we depend on user permissions from the switchboard. So usually your switchboard Asterisk is not going to have root permissions, because otherwise this would be a big security failure. So if we use AGI and we ask it to execute certain things that need role permissions, because asterisk is not it, it's not going to work.
Entonces, esta es una manera a través de la cual podemos
So
trabajar.
this is a way that we can
Para
work
poder hacer lo que queremos,
in,
pues,
but for
tendríamos
what
que
we want
meternos
to
más
do, we would
en,
need
la configuración del dispositivo,
use
¿no?
rather
Tendríamos que
the
cambiar los permisos
device
de carpeta de
configuration.
usuario,
We would need
de
to
los
change
archivos, la
the
configuración.
user,
Es más complicado,
folder,
con lo cual en este caso, lo
files
que queremos hacer
configuration
nosotros
and
no nos
permissions.
vale. Lo descartamos. Nos valdría,
So
pero
this is
conllevaría mucha
not
más configuración, lo cual, en este
useful
caso,
for what we want. So we would
¿cómo
need
sería la
much more
ejecución?
configuration.
Si queríamos,
So
por
how
ejemplo,
would
pues,
we
automate
execute it
metasploit.py,
if we want
¿no? Desde el propio dial plan que hemos
automate.exploit
visto antes, pues sería número de
metasploit.py?
teléfono, coma N,
That
coma
would
AGI, y entre
be
paréntesis
telephone
dentro
number,
de la función AGI, introduciríamos el nombre del script,
N,
del sistema, lo que es la
AGI,
centralita,
and then we
diéramos
would
a esa
include
opción
the
en el número de
script,
teléfono,
and
ejecutaría ese script.
the switchboard
Volvemos a lo
would
mismo. Si tengo
execute
permisos,
that
lo
script
ejecutará. Si
with
no
the
tengo
telephone
permisos,
number
no hará
if we have permissions, obviously, otherwise it wouldn't do anything.
Luego tenemos ejecución de comandos y
Now,
script
how
con la
about
función
command
system.
and script execution
Básicamente en el
with
dial plan es lo
system?
mismo. Sería poner system y entre paréntesis
Now,
comando. ¿Qué
we would
comando?
have
Tal cual lo
system
escribiríamos
and
en
the command
en la
between
línea
brackets,
de comandos
and
de
we would
Linux,
write
por
it
ejemplo.
in exactly the same way that we have it
También, bueno, hay
on
otra
the
serie de
Linux
funcionalidades
command
adicionales
line.
a través
And then
de las
we
cuales
have
podemos interactuar
several additional
con,
functions which allow
datos
us
que
to
puede estar generando
interact
la
with
centralita.
data
Aquí en
that
el
the
ejemplo,
switchboard
con el
is
segundo,
generating. Here on
bueno, el
the
primero simplemente
second
lo que hace es
example,
cargar
the first one is just
el servicio de
to
asterisk. En
reload
el segundo ejemplo,
the asterisk
lo que estamos
service.
haciendo
But
con el comando
with the
system
second
es
example, what we're doing with the system command is
lo que estamos haciendo es
$sign caller ID, $sign date time. What we're doing is recovering call ID, the time and the date, and redirect that to the serial port. Say we have a display on the serial port, and I'm making it show the information in text, for example. So every time someone calls, I would see on my screen the telephone number of the person who's calling, the date, and the time. So this would be a call identifier, basically. We've got other options as well. You can also execute with the whole root, with command, with the system command. But if you want to execute any script of any kind that you have programmed yourself, you have to introduce the whole root, by the way. For example, here we've got home, user, documents, scripts, / I do like this and everyone is hacked.py.
So it depends on the permissions that we have from asterisk. So if we execute something that gives us error, then it's not going to do it. It has to be previously configured. We could do this, but it's more complicated. So we're getting to the AMI asterisk manager interface. This is what I like and what we're going to do. It allows us to connect its connection of a client to an asterisk to execute commands or read events on a TCP or IP. We have our switchboard, and based on the permissions that we have, you can see the file configuration there, manager.conf. We have the user and the password, 1234, my favorite. We can choose the IP addresses that have permission, those that do not. And we have to set this up as a security measure. We have to determine the port through which the communication will be done. And then we have reading and writing permits as well. We can see there are many in all of there, and this would allow us to make telephone calls. We can also modify or change the visualization of the plan. We can look at the backlog of all the calls. We can collect or change the tone for the call when somebody is calling, And that's why I've put it in red. It's the DTMF. And it's just for reading. It's not writing. We're not going to get the asterisk system involved. We're just going to read so that when somebody puts in a number of numbers, we need to be able to see that. So the connection, we're going to do it this way. How do we know if we've done the configuration correctly? We do a telnet using the IP for the switchboard. When we do tests, we usually work with the machine that you're configuring and the port. When you do the execution, if the response is correct, the reply would be what you're seeing on there, trying to connect to the address, and then it says connected to, and escape character and asterisk call manager, and so on. Here in the example, it's 5.0. So the call of death. Let's do a test with this concept. Let's make a call. Just before we do that, I had forgotten about this slide, so let's have a look at this. We need to know how to link it all together. So through the AMI, the telephone will see what it needs to do. So we've got a little script here in Python, and we connect to the AMI service. Here we're specifying the IP address, the port, and the socket connection. The socket connection, that can be through Python to do the actual connection. And we use that port to send the parameters in order to connect. These are very specific parameters. In order to connect with the AMI, it's what you can see down there. The action, 2 points, the username for the person that we've called Arduino, the intro, the username, another intro, the secret with a key, and then 2 intros. This is where we do the sending. The switchboard receives the request, and if it's correct, we connect. And if it's not correct, it would return us saying that it's incorrect or that it's engaged or any kind of other error message. And on the same script, on the top part, we're connecting to the switchboard with AMI. On the bottom, we're connecting to the Arduino with a series port, as we have explained. The connection is very simple. So it's serial.serial, and within the function, we're going to say to which port we're going to connect and the speed of it. In this particular case, I've got the Arduino connected to the device through USB, and this is like in Windows 1 or 2, or in Linux it's called this way. So the TDI would be the denomination of the port and the speed, and we can configure whatever we prefer, and we can configure the speed in Arduino. We haven't changed it in this case. It's in 9,600, so we leave it in that. So we have a little waiting time and initiate a loop. So in that loop, once we have the connection with the AMI and the connection through the series with Arduino, all we have to do is to wait and see what happens. The only thing we have to do in the loop, based on what I received from the communication from the AMI, I do a search, because the AMI will send us information all the time with everything that's going on the switchboard. And in order to figure that information out, and I said we configured it for the DTMF information, all the rest is of no interest to me. If instead of this you want to have a program that manages calls in a company and see what users are on the phone, those that are not engaged, those that are not there, the length of the call, who they are talking to. You can actually do a panel with this system. So AMI is very powerful. With programming, you can do lots of different things. The company I work for, we have it configured in that way. We have a panel, and we use it to manage all client calls. It's very, very powerful, because when a client calls, you have the call ID, and it shows you all the information about that client, so that when you hang up, you've got everything that is ready. You don't have to wait until the user gives you the ID and look for it, access what he or she has got or not got, talk to them. You have it directly, and you have all the background as soon as you hang up. Or in a hospital, for example, imagine the programming there. We can use asterisk. If the hospital has the telephone numbers of all the users, or in this particular case, I'm thinking of a private clinic, as soon as somebody calls, if the number coincides with the list in the on the switchboard, then the person receiving the call would have all the background of the call with that person. So this reduces response times. So if a person has a given illness or issues, then I know how to continue if that person has made an urgent emergency call. That's the difference between looking for the information on that client, if do I have to call the ambulance or not, but it's having the information directly there in front of you. This is one of the good things about automation. I tend to go off a bit on a tangent when I talk about these things. As you can see, we have the automation here, we have the enumeration, and I'm in the loop to wait to see the call and see what number I have. We have the response, we have digit, 2 dots, 1. If it's bigger than 0, I will find that phrase, digit 1, and now somebody's selected 1. So it says turn the coffee machine off. So if I select 1 when I make the call, the coffee machine will turn off. If I receive a 2, it turns the coffee machine on. We saw it in the Arduino script beforehand on the relay panel, through the connection that we have on our series. If I receive a 3, it could be whatever. You can introduce execution commands. I'll execute this different script in Python. You can put in there, or turn on a film. You can put in whatever you want. You can put in a direct command there. And then we could start making the call. We are there at last.
La llamada de la muerte.
So, the call of death.
Nota informativa, ¿vale?
I made an internal configuration, a simulation of the switchboard, and I have it set up. I have the telephone set up with a number that we know from people from the event. So we've used INCIBE's number. So we have 987, 877, 189. That's the number I'm going to call. Nobody's going to pick it to hang up on me, of course. I don't know if the microphone will reach so that you can hear the sound or not. But you will hear an exchange saying that I'm here at CyberCamp. Press 1. Press 2 for this, press 3 for this, press 5, execute whatever script, 7 or 8 for destruction. Okay, so we can configure whatever we want. So this is in a closed circuit that has already been programmed, and I need to say that the number of INCIBE has just been used for for demonstration purposes, and there's been no damage during this process, just to let you know. So let's go ahead and do the call.
Descolgamos.
So we pick up the
y vamos a llamar.
Phone and make the call. Press 1 to activate. 4, 3 to execute a script. So you can hear a little bit of what was coming on the menu there. It turns on and it turns off if we select the right number. So let's go out from here for a moment and go to another screen.
Muy bien. A ver, aquí he preparado.
So here I've prepared what I mentioned before. There are 2 connection screens, so you can see the execution visually. On the right, we have the asterisk CLI. This is in real time. There's an ICE, somebody's picked up the call. There's a playback with the recording. So there's a recording in an MP3 file. In this particular case, it's a different format. It's not MP3 because I don't have it installed on here. It's ULAU. So with any Linux system, you can do all these configurations as well. So after the playback, we can see the execution of the message. We have the connection and receipt of the numbers, and it finishes and hangs up. So if we go to the left, you can see at the top the information that the switchboard is sending to us on the AMI, and even though we close that on the configuration, it needs to be through the DTMF, but we do get a lot of information that it specifies the type of channel that is being executed, the call ID. In this particular case, it's an internal extension. The context that was introduced, the type of language, it's in English. I haven't changed the language to Spanish. There's the number that we called. Then we have some IDs through the connection for the call. And then we have the digit, which is what we are interested in. Turn the lights on or off. I don't know if you're able to see that the LED lighted up. So with the other option, we turn them off with option 1. So now we'll see how the information goes through. This shows you how the information goes through. Keep in mind that rather than an LED display, you could connect whatever you want. And I really mean whatever you want. It depends on how you have programmed this. Okay, we're doing okay with the battery for now, although I have not connected the laptop to the power. So let's get this prepared. Let's repeat the call and have a look at both screens. On the right, you'll see what you get from the CLI, and on the left is the script that we've done, and it's receiving the commands or the information that we have prepared. Let us see how it goes.
Pues, por ejemplo, le damos al 2.
So let's select 2 for example.
Encendemos y apagamos los LEDs.
We turn the LED lights on and off. If we select 4, we execute an nmap. You can see that on the screen. And if we execute command 6, we activate self-destruction. So these are the different commands. On the right, you can see everything that we want to do. And the network that we're using, just imagine that we could have compromised a system. We could activate self-destruction and it would destruct the device. And so people would have nothing to analyze. The analysts would have nothing left to look at. So it depends on the options that you want to give the device. Let's have a look at it once again. Oh dear, I've gone right back to the beginning, but let's just go through quickly.
Consejos y contramedidas, cuando todo es posible.
Okay, so some advice and countermeasures when everything is possible.
We've seen that with computing we can do whatever we want because everyone there's a new system, someone will come and turn it around and use it in the way it shouldn't be used. So what are these things for? So that developers and makers of these systems and devices know in which other ways people can use their systems and hence apply security measures to avoid that. Now, monitoring and control, both virtually and physically. Virtually, for us who work in computing, is what worries us the most and we deal the most. So we monitor communications, we have WAPs, firewalls, antiviruses, the ports used on the network. So that for us is clear. Controlling the ports that are used in the network. So if I am managing a network and I know that there are certain protocols that I'm not using, but when analyzing the network traffic, I see those protocols being used, then I would have to stop them, cut them, ring all alarms and see what's going on. Now, there are many different systems that do this, but you have to remember this. Now, monitoring traffic and blocking everything that's not allowed, listing authorized machines, MAC and IP addresses, amongst others. So we have to always have under control what is connected to the network, and we have to monitor that, and we shouldn't allow any unauthorized connections. Why? Knowing always MAC and IP addresses, and so on, so that I always know which are my devices, and if I have an unrecognized device, I can block it or just not allow it to connect. For example, avoiding the use of DHCP and using honeypots, disconnecting, physically disconnected Ethernet switch hubs or routers which are not in use. What happened to NASA? That they had a rack that was accessible to everyone with thousands of cables where anyone could come and plug anything in that they wanted. Here in the corridors and everywhere I have seen hundreds of network connections. I could connect any device I wanted to and I could work with the network of the building. Now, I don't know if it's being monitored here, I would imagine so, but on the rack where all are concentrated, those which shouldn't be in use or which are not working, then they should be disconnected. And those sockets should only be connected when they are going to be used. Now, if you have a socket when accessing the toilets, for example, I don't think they should be working. But if I plug my computer on, then I have access to the network. Well, on the rack, that should be switched off. Now, actual access to the racks. The best way of protecting that is physical protection, not only where they are, but also they should be in rooms with locking doors and not leave the keys just next to the door. In some places they have a very well protected rack. Then once you get to the rack, you have the key that opens the door stuck next to the lock. Well, that is not very wise, is it? Now, creating isolated networks for guests or between departments. Now, there's something that happens in many places, in restaurants, for example. They've got a Wi-Fi network. I've got my Wi-Fi network, and everyone can get connected to my Wi-Fi network. And that's where I have all my devices, which I use for getting payments from people. I use those systems to take orders from tables, and I have all my clients getting connected freely to that network. Well, mixing your work with what hundreds of people who just pass by can do, I don't think it's logical or normal. Well, that happens every day. You can check, but don't. Now, the best thing in these cases is to have separate networks, a working network and then another network which is exclusive for guests. And if you don't have the resources, then at least create different IP ranges so that there's a little bit of separation. Now, this is from a homemade point of view, not professionally, obviously. Professionally, we've got many other devices. Now, something which is very important is the budget that we destine to cybersecurity is not expense, it's a necessary investment. And what happens usually with the budget that you have for cybersecurity, that you only remember that when you've already been victim of an attack. But that's not how it should do, because I remember, so do I only remember that I have to invest money in cybersecurity when I've already had a ransomware? No, I have to invest beforehand in order to avoid getting that ransomware, because you have to take into account that cybersecurity, in the same way that we're implementing the best technology or spending as much as we can to avoid people coming into our company to burglar us. We have blinds, we have alarms to avoid our company being compromised. But if we work on the internet and we close all doors and lock all doors, but I don't close the internet window, criminals are going to come in through there. If they cannot use the door, they will use the internet. So what company nowadays does not have emails, online shop, website? None. So if you protect your physical shop, then you have to protect your online shop as well. So the budget for cybersecurity should be compulsory. That should be the first thing to take into account, in the same way that I see what I'm going to right above my door, then I have to know how much I'm going to spend on cybersecurity, because I am going to be attacked sooner or later. I don't know when, but it's going to happen. Could be today, tomorrow, or in 10 years' time, but it's going to happen. Through an email, through phishing, one of your employees who wants to sabotage your company because they're angry about something. So there are many ways in which you can prevent those attacks, but you have to be ready. And if you need to, just hire the best people and just have a hacker in your life. And this is all. Thank you so much for being here. If you have any questions, I will be happy to answer.
Gracias.
Hola, ¿se oye? Vale.
Hello. I just wanted to, well, first of all, thank you very much for this workshop. And I've seen that when you are typing, you only get one number. How about if you wanted to introduce an MS IP? Then you need to program it. You would need a loop. Yeah, exactly. Yeah, just take into account that Programming and coding, it's all about imagination. There's no limits. It's just turning it around in your head and see how you can code something. How would I add an IP? With this little device, in the same way that I can change the IP and I can connect through my computer, like with a web interface, I can change everything, the user that is connecting and everything. But what if I don't have a computer? If I have already set up the device at home and I take it to a company and they have a different IP range and I cannot change the IP, because you cannot go and say, let me the computer and I'll change the IP. No, we're not going to let you. You just have to plug it in and have it work. You've come here to set this up, then just do it. So you just take the device, you call the hash tag 4 times, and you go on your setup menu, and first of all, it will know which IP it has configured, everything in English, by the way, and it tells you which IP address you have, and you have the option of changing it. So you choose change, and then it says this is your current IP address, and introduce a new one. And so you would use an asterisk here, which would be, instead of dots for the IP address, and then the hash key. And so I have changed the IP only with a phone. So in the same way that you can do it like this, you can do it on your asterisk switchboard. So just think how you want to do it. There's no limits, because it all depends on your imagination or how good you are at coding. Thank you.
¿Alguno más? ¿Alguna pregunta más? Pues nada. Mira, ahí hay una.
Any more questions? Yes, there's one there.
Sí. También da la posibilidad de que alguien
Is it also possible for someone to be listening into your calls and send the sounds? You mean a man in the middle with asterisk? Yes, yes, you could. I mean, I haven't studied that in particular, so I couldn't tell you in detail how it could work. I know it could be done, but I don't know, I cannot explain how. This comes from the origins of hacking, right? With Blue Box and everything. Thank you.
¿Alguna duda más?
Any other questions?
Pues nada.
Well, this is all. Thank you so much. A round of applause for him, please.